We are trying to use the rational zero test to find all the rational zeros of that function. So that means we have a function right here, 2x to the third plus 11x squared minus 21x minus 90. I will set this function equals to 0 and then solve for x. So let's say x equals to 3 values. That means if you plug in one of the values to x and then you walk through this computation, y is equals to 0. You might say, all right, we can just factor this function, set that equals to 0, and then solve for x. Yes, you can do that, but the purpose of this problem is we are trying to walk through the entire rational zero test. The very first step is part A, use rational zero test to find a list of possible rational zeros and then do not reduce a fraction. So this step is we are using the factor of the constant. So that will be factor. Constant, where is the constant? The constant is negative 90. So that is negative 90 divided by the factor of the leading coefficient. Where is the leading coefficient? That will be the 2. So the entire term, 2x to the third, is a leading term because 3 is the highest power or highest degree, and then 2 is the coefficient of this term, then 2 is a leading coefficient. So that is equals to 2. This is pretty long. The question that you have to ask yourself is, hey, what number times what number is equals to 90? Give me all the possible combinations. I should make the line longer because there are many, many numbers. The first number that I am thinking is 1 and 90, right? So I will be using a plus or minus 1 and then a plus or minus 90. Why do we need to include the plus or minus? Because 1 times negative 90 is negative 90. Negative 1 times positive 90 is negative 90. So that means the 2 will be 1 times 2. You are using plus minus 1 and plus or minus 2. 1 times 2 is 2. Negative 1 times negative 2 is also equals to 2. So that means for each number, you have to include the plus or minus. 90 is an even number. I can do a 2 times a 45. And then what else? 90 is divisible by 3. I can do a 3 times a 30. What else? How about 4? You know what? 4 is not going to work. 15. 5 and 15. 5 and 15. What else? How about 5 and 15 and oh, you know what? Not 5 and 15. 5 and 18. 5 and 18. 5 and 18. How about 6? 6 and 15. 6 and 15. 6 and 15. Are we done? No. 9 and 10. So also 9 and 10. So that is all the possible rational zero. I think the reason of do not reduce the fraction is you have to do one more step. Actually, there is one more step you have to do. I think there is not enough space to do it. That's why they said do not reduce the fraction. That step will be, do you see we have a long list over 1 and 2. So you have to take every single number on top divided by 1, then you get the same thing, right? But when you take every single number on top again, divided by 2, so you have another list of fractions, right? So let's say 1 over 2, 2 over 2 is one that is a repetition, and then 3 over 2, 5 over 2, 6 over 2, so on and so forth. Okay, and then part B is test the list of possible rational zeros. So we have a long list. I'm not saying they are all zero, they are all rational zero. This is only a possible. So the zeros, what is 0? X equals to a number, plug it in there, you get y equals to 0. So those numbers, they are hiding in this list. So the part B is we have to find one of them. But if you are doing this on a test, testing every single one of them, wow, that would just take a long time. So that's why sometimes you get a hint, right? So f of 2 is negative 72, f of 1 is that, and then f of negative 6 is equals to 0. I am looking at this. F of negative 6 is equals to 0, and the negative 6 is right here. So that tells me, what does that mean? until you find 1. Okay, so they actually did it for me, so I will just take this one. I think this is for time saving. F of negative 6, so you have 2 times negative 6 to the third plus 11 times negative 6 squared minus 21 times negative 6 and then minus 90. That is equals to 0. What does that mean? That means x plus 6 is one of the factors. That means x plus 6 is one of the factor. Hey, you might ask me, no. You said f of negative 6, but now you mention x plus 6. So here is what happened. So what we did at this point is, so we have f of x that is equals to x plus 6, and then you have this is a first degree, right? And then you still have a second degree, so that will be a 2x squared, and then the rest we just don't know at this point. Hey, why do we use a 2 in here? Because there is a 2. The leading coefficient is a 2. When you have x times 2x squared, you have x to the third. But at this point, since I only have one of them, the rest, I just don't know at this point. I will find out after the next part. The next part is perform a synthetic division. To perform a synthetic division, you have to draw an L. Should I change color to... I've just change color, okay? So long division, synthetic division. So synthetic division use the coefficients only. That will be a 2 for the third power. First of all, do we have any missing power? No. Third, second, first, constant, no missing power. We are taking the coefficients 2, 11, and negative 21, and negative 90. So that will be 2, 11, negative 21, and then negative 90, and then what number goes here? That number is negative 6, and this negative 6 and this 6, and they must have the opposite sign. If this is a plus 6, then this is a minus 6. If this is a minus 10, then this is a positive 10. If this is a minus 50, then this is positive 50. They must have the opposite sign. So this and that, they must have the opposite sign. Let's put a note right here. Opposite sign. All right, opposite sign. How do you perform a synthetic division? You pull the first number down, so that will be just a 2. You just pull it down. We are not doing we didn't do anything. And then 2 times negative 6. 2 times negative 6 is negative 12. And then you calculate the sum. The sum is equals to negative 1. Negative 1 times negative 6 is 6. The sum is equals to negative 15. Negative 15 times negative 6 is 90. And then the sum of that, this is equals to 0. In fact, this must be equals to 0. 0 is a remainder. This remainder is equals to 0. So when the remainder is equals to 0, so that means x plus 6 is one of the factors. Is one of the factors. And then what else? How about the 2, the negative 1, and the 15? So these are the coefficients and the constant. Starting at the negative 15. The negative 15 is a constant. And then the minus 1 is the coefficient of the first power. So that will be a minus 1x to the first. And then the 2 is the coefficient of the second power. I'm not saying the 2 is a power. If this is a 12, then you have a 12x squared. So this will be a 2x squared. Once again, if this is a 12, then this will be a 12x squared. If this is a 25, then this is a 25x squared. Coefficient 2, coefficient negative 1, and coefficient, no, not coefficient, then the constant minus 15. So now we got this, right? And then the next step, I can factor the quotient in part C. So that will be a 2x squared minus x minus 15. You're going to factor this. You can use any methods you like. So the factor is equals to a 2x plus 5 and then a x minus 3. So that those are the two factors. If you want me to go over this, that is fine. I can do real quick. I will be using a diamond method. The number that goes to the top is the product of the constant and the leading coefficient. 2 times negative 15 is negative 30. And then the coefficient of the first degree is -1. You have to come up with two numbers such that the product is -30, the sum is -1. Can we try a 5 and a -6? Product is -30, the sum is -1. Since the coefficient is a 2, you have to do a 2x plus 5 and then a 2x minus 6. You are going to ask me, hey, no, wait a minute. 2x times 2x is a 4x squared. You have a 2x squared, so is this wrong? Because you are missing the divided by 2. When the leading coefficient is not 1, you have to divide it by 2 and you have to factor a 2 from top from either one of the factors to get rid of the 2. So that will be, I will just take the second one. So 2x plus 5 and then I will take a 2 from here, x minus 6. The reason I picked the second factor is because the second factor has even. 2 and 6 are even. And then you divide it by 2. Once you get rid of that, then you have the, 6, 3, right? You factor out a 2. So once you get rid of the 2, well, and then you get the factors. Okay, what did we just do? So what we did in part C is we have a, what do we have at the beginning? So we have a, I'm going to write this in a different color. We have this at the beginning. So we have 2x to the third. And then plus 11x squared minus 21x and then minus 90. First of all, in part B, I found x plus 6 is one of the factors. I divided by x plus 6 and then I get 2x squared minus x minus 15. And then I factored the rest. So at the end of the day, what do I have? At the end of the day, so the function is equals to, this is the first factor, x plus 6. That is where we pick up. And then we also have this and that. So that is a 2x plus 5 and then x minus 3. So that is the factor form of the function. And then I asked for the factorization. So all you have to do is you simply put the functions in here. So f of x equals to x plus 6 and then 2x plus 5 and then x minus 3. So what happened when you set this equals to 0 and then you find all the zeros, right? So x is equals to -6, x is equals to positive 3, and then x is equals to 2x minus 5 equals to 0. So 2x is equals to 5, then x is equals to 5 over 2. And then 5 over 2. So those are the rational zeros. Why do we use the word rational zero instead of 0? Because this is a rational function. This is, sorry, not rational function. This is a fraction. Okay, this is a fraction. Rational function is a fraction, right? A polynomial divided by another polynomial. And then this 3, is 3 a fraction? Yeah, 3 can be written as 3 over 1. Okay, so that is the end of this problem. If you think my instructions is clear and helpful, give me a thumbs up, subscribe to my channel for more contents like that. As always, I will meet you all in another video. Signing out.